let's move to the another subject, that is power electronics, which is also allied topic for electronics engineering branch, because power electronics is a electrical engineering subject. Now let's start with that one. So before starting this topic, as you already know about this topic, because you have already studied this kind of topic in your analog electronic circuits. So what is that one is, I'll take a simple diode rectifier with pure resistive load. Simple half wave diode rectifier with a pure resistive load, and if I connect this one to a voltage source, that is Vm sin omega t. As you already aware of this topic, so I hope you know very well about this topic, because what is the things you know, this diode will conduct for only first half cycle, in the next half cycle this diode will be turned off. So these things you might know, and you have derived some output voltage expressions like V naught equal to Vm by pi, like this you might have derived this one. But few more additional topics will come into picture if you come to the electrical engineering, that is power electronics subject. So both are same, we are discussing about the rectifiers, but in power electronics we'll deal with different devices, like instead of diode we'll replace this diode with SCR or thyristor. So because of that one, the diode is an uncontrolled device, but the SCR is a controlled device, means one state of your SCR can be controlled, turned on will be in our control, turn off will be decided by the supply. Yes or not? So these are additional topics, as well as here, apart from this average value calculations, apart from this output voltage waveform drawing and all, there are few more terms will come into picture. Average output voltage, average output current, source voltage, source current waveforms, diode voltage, diode current, as well as what is the conduction period of your diode, and what about the peak inverse voltage of the diode. So these are all the things, extra things which comes into picture for electrical engineering students when compared to the electronics. So let's discuss that one. Okay, first let us analyze this entire topic directly. So when diode will be turned on, so if you want to get the status of your any diode, what do you need to do? First you need to open circuit the diode, then you need to measure or you need to calculate the voltage across the anode to cathode, Always your anode voltage, whenever anode voltage is more positive when compared to the cathode voltage, then your diode starts conducting. If it is an ideal diode, both are, if it is ideal diode, just after zero, your means if voltage crosses the zero voltage, just after means 0.0001 also, your diode will immediately conduct. If it is a practical diode, there will be a cut-in voltage of 0.7 volts for silicon and 0.3 volts for germanium. So until the voltage reaches to 0.7, your diode will be in off state. Okay, so these are the things. Now let's draw the output voltage waveforms for resistive load. Okay, so this is the omega t, and what about the supply voltage? Supply voltage is sinusoidal like this. Now let's draw the output voltages. Okay, yeah. So from here to here, the supply voltage is positive. So because of the positive supply voltage, your diode will be forward biased. Because of this one, your diode will be turned on. Once the diode is turned on, how the circuit looks like? The circuit looks like this one. So what is the output voltage you will get? Output voltage is equal to your source voltage. What is the source voltage in the positive half cycle? This is your source voltage. So changing in positive sinusoidal nature. So the same voltage you will get here. And what about the negative half cycle? Supply is negative, means this point becomes negative, this point becomes negative, and this point becomes positive. So because of this one, your diode will be turned off. Once the diode is turned off, the circuit looks like this one. So what happens to the output voltage? As there is no current flowing through the resistor, your output voltage becomes 0. So this is the output voltage. Again the same thing here, just like 0 to pi. 0 to pi, 2 pi and 3 pi, like that. So this is the output voltage. So whenever diode is turned on, what happens to the voltage across the diode? It will be 0. Whenever diode is in off state, what is the voltage across the diode? which is same as your supply voltage, which is same as your supply voltage. So this is the supply voltage polarities, this is the diode voltage. So positive is connected to positive, negative is connected to negative of your supply. So whatever the shape of your supply voltage is there, the same shape you will get the voltage across the diode. What is the shape of your voltage, supply voltage? It is in negative half cycle. So this is the voltage across the diode. This is the voltage across the diode. This is the voltage across the output voltage. So what happens to the current? The current waveform will be same as your output voltage. Current will be same as your output voltage. So this is your output voltage. This is your output current. So these are the things. And how much time period your diode is conducting means from 0 to pi. From 0 to pi. Here my another question rises here. Is this diode can conduct after pi? Is there any possibility to conduct this diode after pi? Yes or no? Most of the students will say no, but that is a wrong misconceptual knowledge, because they always think that resistive load in their minds, and they will say that this diode will only conduct for 0 to pi. After pi means that is pi to 2 pi, your diode will not at all conduct. Okay, they chooses this R resistive load as a thing, and they will generalize themselves like that. This diode will conduct only from 0 to pi. From pi to 2 pi your diode will not conduct. But that is a misconceptual knowledge, because this diode conduction depends on the type of load. Depends on the type of load. So if it is a resistive load, the conduction angle will be pi. If it is an inductive load, the conduction angle will be more than pi. That's we will see now by using another circuit, half wave diode rectifier circuit with a pure inductive load. So this is the pure inductive load, this is Vs, this is V0, diode inductor. Now I need to calculate the current I, okay, and voltage V. So how will calculate the voltage across the inductor? That is equal to output voltage. How will calculate? L into d I naught of t by dt. So from this one, what is I naught of t? 1 by L into integral V naught of t into dt. So from this one, when diode is in on state, what happens to the voltage across the output? Which is same as your supply voltage. So your output voltage is equal to same as supply voltage, that is Vm sin omega t dt. So from this one, so what you will get? So if you derive this expression V naught of t, which is equal to Vm by L, that is omega L, into integration of sine, you will get minus cos omega t plus some constant k, because of the integral constant. So how you will get the constant value of this one? So here we are calculating the I naught of t. Here we are calculating the I naught of t. So what is the I naught of t? Actually, this is I naught of t, sorry. So I naught of t, what is the initial condition means at omega t equal to 0, because before this diode turned on, your voltage current through the inductor is 0. So at omega t equal to 0, I naught of t equal to 0. So if I substitute this value, I will get the value of k as k is equal to Vm by omega L into cos omega naught t. So from this one, what is the final current expression I naught of t, which is equal to Vm by omega L into 1 minus cos omega t. 1 minus cos omega t. This one. So from this one, so if I substitute at different values of your instants in from 0 to pi, let's draw the voltages, let's draw the waveforms for this one. Supply voltage, which is equal to like this, and this is about the current I naught of t. So what is the I naught of t expression you got? I naught of t is equal to Vm by omega L into 1 minus cos omega t. So at omega t equal to 0, this is the first condition, pi by 2, pi 2 pi by 3, 2 pi by 2, 3 pi by 2, 4 pi. So this is the thing, 4 pi by 2, that is 2 pi. So under this condition, when I substitute 0, cos 0 is 1, this value becomes I naught of t is equal to 0, you will get here. What about here? I naught of t is equal to how much? Pi by 2, this becomes Vm by omega L. What about here? This becomes I naught of t is equal to 2 Vm by omega L, you will get. Here you will get Vm by omega L, this becomes 0. So if you observe the current waveform, how the current waveform is changing? So the current waveform is shifting, the current waveform is shifting. The current waveform is changing from 0 and reaches to maximum value at what angle? At omega t equal to 2 pi. So this is the pi, which is equal to 2 Vm by omega L. This will be Vm by omega L. Okay, so the current changes like this. Okay, so let me take blue color. So this is the current waveform. This is the current waveform. Now at this time period pi, your device, what is the voltage across the device? It will be 0. So your device tries to turn off. Once the device is turned off, how the circuit looks like? Open circuit. So if open circuit is there, what happens to the current? Current will reach to 0. What is the basic property of your inductor? Inductor will not allow sudden change in current. So if there is a chance that if voltage if current through the inductor is suddenly changes to 0, immediately what happens? Immediately it will produce a huge voltage. Because of that huge voltage induction across the inductor, the device will be maintained in on state only. Device will be maintained in on state, because here this is the value of current, and this current will already store some energy in the inductor. So if you are trying to make that energy as 0 in 0 time, means that is not at all possible in practical situation, because law of conservation of energy will be violated if sudden change in current occurs in 0 time. So this is the place where your inductor stores energy. This is the time period where your inductor stores energy. The same time period it will take to release the energy. So here this is the storage time, this is the storing time, and this is the releasing energy storing time. This is the energy releasing time, energy release. So how much amount of energy how much amount of time period duration your energy is stored in this circuit? Pi, that is 180 degree it is stored energy. Another 180 degree it took to release the energy. So the same device is storing energy from source, and the same device is releasing the energy to the source. So this is the source and this is the load, that is inductor. So this is the source. See here, this source is supplying energy, to the inductor over a period of 0 to pi. What happens if the energy is completely stored by this source to this load? Now this inductor is have more energy storage when compared to the source, because source has 0 energy, but this inductor have more energy when compared to source. So what it will do is, it will release the energy to the source again. So is there any intermediate element connected in between source to inductor? No. So how much amount of time it has taken to store the energy from source to inductor load? It is pi, that is 180 degree. The same inductor again releases the energy to the same voltage source. How much time it will take? By using the same principle previously, how much amount of time it has taken to store the energy, the same amount of time it will take, because there is no intermediate element is connected. So this inductor will again release the energy in another 180 degree time period. So during this process, your diode will be in on state only. So what is the conduction period of your diode? 0 to pi, your diode is conducting. From pi to 2 pi, your diode is also conducting. So what is the total conduction angle of your diode? The total conduction angle of your diode is 2 pi, which is equal to 360 degree. 2 pi, which is equal to 360 degree. So like this, you need to analyze each and every circuit in power electronics. Okay, this is about the power electronics basic concept. Now let's solve 2 to 3 problems regarding this concept. Okay, so this is the first question. So what is the question is, find average and RMS values, across diode, voltage, average and RMS voltage values across diode. Means here we need to connect a voltmeter. Okay, so this voltmeter is first time it will be a MC type for average value, another time we need to connect MI voltmeter to get the RMS value. So this is how you need to answer this question. Now how will we have to analyze this one? Means for any question in power electronics, mainly you need to draw the output, means waveforms according to the question. Okay, so here we need to calculate the voltages across the diode. So to get the voltages across the diode, so diode has two states. One is on state, another one is off state. One is on state, another one is off state. So if you take the on state into consideration, when diode is in on state, what happens to the voltage across the diode? Voltage across the diode becomes 0. When diode is in off state, then only you need to take the thing into consideration, because here the voltage across the diode will be non-zero. So because of the non-zero voltage value, you have to check the waveform and you need to calculate the values accordingly. So if it is a MC instrument, you need to calculate the average value. If it is a MI instrument, you need to calculate the RMS value. So first let's draw the voltage across the diode waveform. To get the voltage across the diode waveform, first let us draw the source voltage, then draw the current waveform, because we know the current waveform, right? So what is the current waveform of this circuit? The current waveform of diode looks like this one. Yes or not? So this is the current waveform. Means diode is carrying current over 360 degree. Means if any device is carrying current, can we say that device is in off state or on state? It will be in on state. So here, from here to here, diode is in on state. From here to here, diode is in on state. So if diode is in on state, what happens to the voltage across the diode? What is the voltage across the diode you will get? It will be 0, right? Voltage across the diode, it will be 0 like this. So if voltage across the diode is itself 0, what happens to the voltage average value and RMS value? Average value will be 0 because voltage is 0 already. So the average voltage across the diode is equal to 0. The RMS voltage across the diode is also 0. This is the answer for this question. So once you know the concept very well, then it will be easy for you to answer any type of questions. Okay. Now let's move to the next question. So the next question is same question. I am introducing new question. Find the average and RMS voltage, again average and RMS voltage across load L. So here across this inductor you need to calculate the average and RMS voltages. Okay. Now to get this one, So what you need to do? You need to connect a MC instrument one side one time, MI instrument another time. Then you will get the value by using measuring condition. So this is how you will measure the voltage. But instead of this one, you can calculate also directly. So let's calculate the voltage first. So diode is continuously in on state, right? Over a period of 360 degree, diode will be in on state. So this is your source voltage and this is your voltage across the inductor. So how much time is this diode is in on state? Diode will be in on state for a period of how much time period? The conduction period of your diode is 360 degree. Means over a period of 360 degree, your diode is in on state. So this is your source voltage. Okay. So omega t. Now let's draw the voltage across the inductor waveform. Once the diode is in on state, what happens to the voltage across the inductor? By using KVL. So what is the voltage across the inductor? VL of t, which is equal to Vs of t. Means your inductor voltage just follows the source voltage. Your inductor voltage just follows the source voltage. How the source voltage is changing? It is from 0 to pi it is positive, from pi to 2 pi it is negative, like this. So this is the voltage across the inductor. Now what is this waveform? This is a sinusoidal waveform. So what is the average value for any sinusoidal waveform? Its value is 0. Average value for this sinusoidal waveform is 0. So V naught, that is average output voltage will be 0 volts. What happens to the RMS output voltage? As you already know that, what is the RMS voltage for sinusoidal waveform? If you have a sinusoidal waveform, so what is RMS? How you will calculate the RMS means you just take the peak value, divide that peak value with root 2, you will get the RMS. So RMS output voltage is equal to, peak value is how much? What is the peak value? This one Vm, here also Vm. So Vm by root 2. This is the RMS output voltage. Understood or not? So once you once you start analyzing the concept, or once you start drawing the waveforms, then it will be easy for you to answer the questions from power electronics subject. So once you got the waveform, then it will be easy for you to answer, because remaining everything you have in your fingertips. Okay. Now let's move to the last question. What is the last question? Is this one, same question. I am just extending the question value. Find the average and RMS value of load current. See here, now we need to calculate the load current average and RMS value. For that one, I have to introduce a ammeter in series with the load. Okay. Now, as we already know the load current waveform, that is inductor current waveform only. So how will get the inductor current waveform average and RMS values means? So this is your source voltage and this is your load current omega t. This is your load current, output current. So the current value will be looks like this. Okay. So this will be your Vm by omega L. This will be 2 Vm by omega L. Now what is the current expression we have? What is the current expression, output current expression we calculated previously? It is Vm by omega L into 1 minus cos omega t. So if you elaborate this one, Vm by omega L minus Vm by omega L into cos omega t. Now this current is a combination of a DC component along with the AC component. So if you have multiple source values, which is the best method to calculate RMS value means by using root mean square value. Yes or not? So by how we will calculate the RMS value for this current? The load current RMS value is equal to square root of root mean square. What is the first component? DC component, that is Vm by omega L whole square, Vm by omega L whole square. And what about the next component? We have next component is AC component. What is the RMS value for this component? Because for DC, average and RMS both are same. But for AC, what is the RMS? Take the magnitude value, divide that magnitude with root 2, you will get the RMS value. So root 2 omega L whole square. So from this one, what is the RMS values? So if I take the Vm by omega L as common, so what you will get? Because square root gets cancelled in both the thing. So 1 square plus 1 by root 2 whole square. So this becomes 1 plus 1 by 2, it is 3 by 2. So Vm by omega L into root 3 by 2. So this is the RMS current of your load. RMS current of your load. What about the average current? Average current means this is the average current, because average current means that is DC current, because the average value of this AC component becomes 0, right? So this is the DC component, its average and RMS value both are same. What is the average value for this AC component? It will be 0. Average is 0 here, average will be this value. So what is the final average current? Average current, output average current I naught, which is equal to Vm by omega L. Vm by omega L. So like this, you need to solve different number of problems based on each concept. Okay?